So basically, when you view, say, a moon without a telescope using your naked eye, you see it at certain angular size that is about ½ a degree. But when you use the telescope with the eyepiece that serves to magnify the size of the image, then you see the moon at the larger angular size, right? Its size is magnified. But there is a catch, that as you go to a larger magnification, which you achieve by just changing the eyepiece of the telescope. Objective is fixed. That's the most expensive part of any telescope, the objective. The eyepiece lens is quite cheap because it's small, and you get a set of eyepieces that you can change, okay, to increase the magnification. But as I said, there is a catch here, and the catch is as follows. As you increase the magnification, so here is the view of the moon at the magnification of 50. Here at the magnification of 100, which you achieve just by changing the eyepiece on the telescope. Objective is still one and the same. Here is the magnification with yet another eyepiece, where you achieve the magnification of 250. But as you increase the magnification, the image becomes fainter. Why? Because look, if the focus is this large impact crater here, okay? So this is the area here reflecting the light that is directed towards the telescope. Now, the same amount of light is spread to a larger area. So therefore, I have less light per unit area than at the lower magnification. Even at the higher magnification, right, all of the light reflected by this area here is now spread over even bigger area. So I get less light per unit area, which is actually brightness of the image. So as I increase the magnification, the brightness goes down. And the magnification or magnifying power of a telescope is the least important of all powers. If you are considering perhaps buying a telescope, which I would not advise you to do right away, the best strategy for somebody who might be interested in doing some viewing of the night sky is first get a good pair of binoculars. You can see quite a bit with a good pair of binoculars, okay, compared to what you can see with the naked eye. And then if you enjoy stargazing, then you might consider buying a telescope. And keep in mind, when you go to a store, although most stores, the people are pretty good, is ignore whatever magnification the telescope has. Just look at the light gathering power of the telescope, which is determined by the diameter of its objective. Magnification is achieved just by changing the eyepiece. And it turns out that the magnifying power of a telescope is given as the ratio of the focal length of the objective over the focal length of the eyepiece. And you can increase it by going to the eyepiece lenses of smaller and smaller focal length. But as I explained, there is a price that you pay, is that your image of whatever you are viewing, as you go to the higher magnification, is reduced in brightness simply because one and the same amount of light gets spread over the larger area as you increase the magnification. Okay, so if I have a focal length of the objective, say 1 meter, which is 100 centimeters, and the focal length of the eyepiece is 1 centimeter. 100 centimeters, which is 1 meter over 1 centimeter, is 100. So that combination of focal length of the objective and focal length of the eyepiece is 100. If I would use an eyepiece that has a focal length of 0.5 centimeter and still the same objective, which of course I do because that's given with my telescope, you don't change objectives as you do eyepiece lenses. If I go to 0.5 centimeter focal length of the eyepiece with 1 meter focal length of the objective, I would get a magnification of 200. So that's something to keep in mind, that cranking up magnification won't do miracles, because as you increase magnification, the brightness of the image goes down.